Alright guys, he says that flaws in a certain type of drapery material appear on the average of 1 in 150 square feet. If we assume a Poisson distribution, find the probability of at most one flaw appearing in 225 square feet. First thing, the rate lambda is 1 out of 150 square feet. Now, second thing is, we need to find the new rate of lambda, which is 225 out of 150. Now, I'm going to say this. If there is one flaw out of 150 square feet, one flaw out of 150 square feet, then we need to find the probability that we have in 225 square feet, how many flaws we are going to find. So basically, this is what it is. They're asking you, what is x if you have 225 square feet? Now, I'm going to explain this in a different way now. What they are saying is, you have 150 square feet, and in that 150 square feet, you find one flaw. Now, the 225 square feet they're asking about is not a different one. It's in the same square feet, which is just extended. So let's say you have like a square like this, a square, and that's 150 square feet. Then it's like, what if we just extend this to here, and see that one now is 225 square feet, how many floors we would get, basically. So it's not that we have 150 square feet here, and then we have another 225 right here, no. It's the same part, it's the same thing, except they extended it from here to here, and we're trying to find how many floors we can find in that new set. Now, let's try to put this in application. We know that the lambda is equal to 1 over 150 because that's what the original square feet, floor per square feet is. The new lambda now we are looking for is the probability that we have now 1.225 over 150, which is 1.5 when you divide it by, if you want to divide 225 by 150. Basically, what is this x going to be equal to when we find the probability of having one flaw in 225 square feet? So, what it is the probability of finding x at most one flaw less than or equal to one flaw would be the probability of, which actually would more likely be, if you use your calculator, you would have this to write a summation, because it's a Poisson. Remember, the Poisson process is, the Poisson distribution is e to the negative lambda times lambda to the power of x over x factorial. So basically, you would type e to the power of lambda. Now, lambda is 225 over 150. Or negative. Let me just add up and we write that again the other way. Over 150 times lambda 225 over 150 power of x divided by x factorial, comma x, comma 0, comma 1. Now, if your calculator does not like when you type it like this, you could type it as summation e to the negative 1.5, or you divide 225 by 150 times 1.5 to the power of x over x factorial, comma x, comma 0, comma 1. And now let's use our calculator here. So we would have to click on F3, number 4, and type the green button E, negative 1.5, close parentheses, times 1.5 to the power of x, comma, nope, divided by power of x divided by x factorial second 5 7 1, and I forgot the x, comma x, comma 0, comma 1, and close parentheses, and type it in. Then your answer would be equal to 0.558. So guys, this one is probably one of the hardest things you have to remember how to do, because here they gave you two types of lambda. Basically they gave you two types of lambda. You would have to find the second type of lambda, not the first one, because the first one is the original, but the second one is what they extended. So they want you to find for the extended part, the extended one, not the original one. So I hope you guys understood the video and that it helped you with your homework or either exam or whatever it is. But if you guys watch the video, thank you for watching it, and I hope you understand. I hope it helps you in the future. And as of right now, that's about it. I will see you guys another time. Bye.